Okay, this is the notes for section 3.3, the graph of ax plus by equals c. We're familiar with graphing lines in slope-intercept form. What we want to do today is we want to look at graphing something in standard form. So when we look at ax plus by equals c, where both a and b are not both 0, we know that that's a line, and we call that the standard form of an equation for a line. So anytime we have it in the form ax plus by equals c, we call that the standard equation for a line. Well, we can also graph a line in that standard form, and the way that we do that is by using its x and y intercepts. Okay? Because we know that when we graph a line, we only need 2 points, because 2 points determine a line. If we can figure out what the x-intercept and the y-intercept is, which we can very easily from the standard form, we can quickly graph the line without having to put it into slope-intercept form. Okay, so let's take a look at this first example problem. It says graph the equation 3x minus 4y equals 24 using its x and y intercepts. So you'll notice that equation is in standard form, and your a value is 3, your b value is -4, and your c value is 24. So what I'm going to do is I'm going to first find my x-intercept, and then I'm going to find my y-intercept. Well, to find my x-intercept, really what that means is I'm going to let y equal 0 and solve for x. So if I take a look at this, I have it right here. It says, so if I let y equal 0, I have 3x minus 4 times 0 equals 24. Well, 4 times 0 is 0, so really it's almost like I'm just covering up this y term and solving for x with 3x equals 24. Okay? And to do that, then I can divide both sides by 3, and that's how I'm going to end up with x equals 8. So that would be the x-intercept. Okay? And then the y-intercept, to do that, I'm going to do the same general idea, except for this time, what I'm going to do is I'm going to let x equal 0. Okay? Well, if I let x equal 0, it's like covering up this part of the statement, and I'm just looking at -4y equals 24. Okay? Because 3 times 0 is 0. So -4y equals 24. Then if I divide both sides by -4, I can get my answer, which is y equals -6. Okay? So once I've done that, then what I'm going to do is I'm going to graph those two. Now if I have x equals 8, that's on the x-intercept. I'm going to look for the point where it's equal to 8 and plot that point. Okay? And I'm going to do the same thing with y equals -6, but now that's going to be on my y-axis. I'm going to go down 6 units to plot that point. So when I do that, here's those points. Okay, so I've got 0, -6 for my y-intercept and 8, 0 for my x-intercept. I can then just draw in my line going through those 2 points, and this would represent the graph of 3x minus 4y equals 24. Okay, the method that we just worked on in example number 1, finding the x and y intercepts, only works if a and b are not 0. If a equals 0, then we're going to end up with an equation of a line that is horizontal, and if b equals 0, we're going to end up with a line that is vertical. Okay, and we know that a horizontal line has a slope of 0. And we know that a vertical line has a slope that is undefined. So if I take a look at this example right here, using the axis above graph 0x plus y equals -2, well, if I have 0x plus y equals -2, that's the same as saying y equals -2. So when I do that, I'm going to graph the line y equals -2. Okay, so if you want to go to your graph up above, if you want to graph that line, and then I'm going to show you that in just a second here. Okay, so here's what that line would look like right here. Y equals -2, you'll notice that it is a horizontal line. Its slope is 0. And you can think about that because you have the number in front of your x term is 0. It would make sense that our slope would be 0. So it'd just be a horizontal line at y equals -2. So if you know your y value and you know it's a horizontal line, you just go ahead and graph a horizontal line through that particular y value. Okay, so standard form is a great way of working with linear equations. There is one drawback, however, and that one drawback is that when we have something in standard form, there could actually be many equations that are equivalent equations written in standard form. So any equation that is a multiple of another equation would be equivalent. So in order for me, or in order for us to check to see, if equations are equivalent to each other, what we can do is we can put them in slope-intercept form. So let's take a look here at example number 3. It says, which equation, if any, represents the same line? Well, we have 2x minus 4y equals 12, 2x plus 4y equals -12. They're all similar looking. So let's just take a look. To do that, what I'm going to do is I'm going to put each one of those into slope-intercept form, and then once they're in slope-intercept form, if they're the same, their slope-intercept form will be exactly the same. So let's take a look at that. So here's each of those in slope-intercept form. Okay, so I'm solving for y, putting that x term first, and you can kind of see what I did for each of those. Make sure you get down the work on these as well. When I do that, you'll notice that both b and d, you ended up with y equals -1/2 x minus 3. Therefore, b and d are equivalent equations. Okay, and if you look at the 2x plus 4y equals -12 and 3x plus 6y equals -18, if this one here is a multiple of this one here, so if I take it, I multiply b by 3/2 or d by 2/3, I would get the other equation there.